Converting decimals to fractions, right. Okay, first decimal I'm looking at here, 0.3. That is 3/10 I'm looking at there. Okay, so as a fraction that is 3/10, 3/10. Okay, the second one, that number there represents 2/10. That one represents 3/100. So together there's 23/100. Okay, down here, same sort of process. You look at the last number, is that tenths, is it hundredths, is it thousandths, is it 10,000ths, millionths, so on and so forth? Well, tenths, hundredths, thousandths, so my divisor for my fraction is 1,000. Then how many have I got? I've got no hundreds, 110 and 17, so that's 17,000. Okay, that's converting decimals into fractions. Fractions into decimals is a touch more difficult. Okay, and I'll just want to go through one main example for this. Right, the example being 7/8. Right, 8, you can't multiply 8 up. You can't multiply it up into 100 and work it out as a percentage and then convert that into a decimal. You're just going to have to go through the route of long division for this one. Okay, so you're dividing by 8. So 8 goes on the outside and 7 goes on the inside. Okay, I'm just extending my divider here because I know what's going to happen. Okay, whenever I come to converting fractions to decimals, I'm going to end up with something which is, in this case, less than 1. So I'm going to add on a few zeros there. 3 is probably the most conventional one to do. Right, how many 8s are there in 7? There are no 8s in 7, and because I haven't used anything, there's 7 left over. Okay, on to the next one. How many 8s are there in 70? Well, there's 10 8s in 80, 9 8s in 72, so there's 8 8s. Okay, 8 8s with the remainder 6, if I've got that right. Okay, then I'm going down the process of how many 8s are there in 60. Right, I can count on my 8 times table. When I do that, I'm going to realise that there's actually 7 8s in 60. Okay, and that leaves you with the remainder of 4, because 7 8s is 56, remainder 4 in this case. Okay, how many 8s are in 40? There are 5. There's nothing, no remainder now, so I can stop at that point. This is a terminating decimal. So this means that 7 8s is equal to 0.875. Okay. Probably the most critical thing here is to put your decimal here and have it above as well. You're recognising that that number is less than 1, you're expecting that. 7 8s is fairly close to 1 and 0.875 is fairly close to 1. All this is giving you additional evidence that you're right, or you're along the right track. If I type that into the calculator, straight 7 divided by 8 and hit the equal sign, I get 0.7875. Okay, so that's why in this case it wouldn't be on a calculator paper, because it's too easy. You just type it in, press the equal sign, and it works. So this would probably be the most basic process to go through. It's going to work every single time. Sometimes your decimals are going to keep on going. If you've got something like, say, 2/3, then if I do that one very quickly, you're dividing by 3, you're going to start by dividing by 2, stick my decimals in, 3's into 2, there aren't any, remainder 2. Okay, 3's into 20, well there are 6 3's in 20, remainder 2. 3's into 20, there are 6 3's in 20, remainder 2, and so on and so forth. And it's going to go on forever, okay? And that's because 2/3 is 0.6 recurring. So at some point there you're going to terminate your decimal and you say it's going to be 0.666, or if you're really smart, you're going to say that's 0.6 recurring, going on forever.